Good morning. I hope you are enjoying power electronics. Today we are going to study the DC-DC converter. This DC-DC converter means the converter which is used to get variable DC from fixed DC voltage. Right? So that we will going to study today, and this DC-DC converters are used at several places, like our DC motor speed control. We know that the by changing the armature voltage we can control the speed of DC motor, isn't it? So there we can use our chopper, means from fixed supply we will get variable DC voltage. Likewise, these are used in electric vehicle system. They could be used as battery charger. They could be used to provide variable DC link in case of external voltage control of our inverter. Right? For that purpose, they are used. Now, we can say it is something like the transformer. In transformer, the supply is AC and it changes the magnitude of AC voltage, either step up or step down. Similarly, you have DC-DC converter which are known as chopper, They can step up or step down the DC voltage. The chopper which is used to step down the DC voltage means output is always less than the input voltage. That chopper is known as buck chopper. Likewise, the chopper which is used to up or increase the voltage from the input level, that is known as boost chopper. Clear? Now let us understand the principle of step down chopper, which is also known as buck chopper. Here we must understand what type of device, what type of power electronic switches we should use. Right? See what we want. Whenever this switch is on, the input voltage is applied here. Whenever the switch is on, input voltage is applied at the output. So what type of switch we should use? We should use either MOSFET or IGBT. No doubt thyristor can be used, but at the same time the switching frequency is low. And not only this, you have to use the force commutation. So additional circuit cost will increase. That is why we use either IGBT or MOSFET. For low power application we use MOSFET. For moderate we would use IGBT. Clear? So when we apply the gate pulse, this switch is on, and this input DC voltage would appear at the output as VDC. And when this switch is off, output is 0. Why it is 0? Because we have connected one freewheeling diode. If it is a resistive load, the current gets 0, so output voltage is 0. But if it is a RL type load, then current, after when we turn off this switch, the current will flow like this, because the inductor which was the part of the load, that will develop a polarity in such a way that this diode would come in the forward bias, because in what inductor wish, it try to not to decrease this current, so it will develop a voltage in such a way that current is flowing through this diode, it is flowing through this freewheeling action like this. Now there are three cases possible. One is discontinuous mode of conduction. For RL load, it is discontinuous mode of conduction, means this is the total time period. T on, switching on time plus switch off time. This is the total time period. So during the entire time period, for some duration, current is 0. That is discontinuous mode of conduction. Now when this current is 0, output is 0. I have considered the RL load. When we will consider the RLC or RLE type load, then of course the back EMF would come during this period, right? Now if the current is critical continuous conduction, means the point at which current is 0, at the same time you have turned on the switch, so current is start increasing at this point, means when the current is decreasing at this point, at the same time it is start increasing. So this is the critical continuous mode of conduction. During this period, during T on, switch is on and current flow through the switch, and when the switch is off, the entire period current is flowing through the freewheeling diode. And if it is a continuous conduction, then all the time current is flowing like this. It has its value either I min or I max, means all the time a small amount of current, small means this I0 current is flowing all the time, and it is having ripple from I min to I max, means the minimum value of I0 is I min, the minimum value of load current is I min, right? This is I min. One can think, sir, we have turned on the switch here, we have turned on the switch here, how it is possible that inductor start with this current? The reason is we have drawn this current as a steady state current, right? This current is steady state current, not at t equal to 0. See, at t equal to 0, it will start with 0, the current will start at 0 and down, then from here it will increase and then down, means after 2-3 cycle the current acquire the steady state value, means it is always come at I min value, right, and go up to I max value. Here it is start from 0 and after few cycle it is come under the steady state. So we have we are showing the steady state waveform, right? And we have already covered studied all this thing in the your single phase rectifier, right? If you remember, in case of any confusion, you can go through there as well. That those lectures are already available on the YouTube. Now, if we talk about the average output voltage, the output is appearing for the duration of T on. Output is appearing for the duration of T on. So the total time period is 1 by the total time period is T. So 1 by T integration 0 to T dt, and up to T on VDC appear, and after that it is 0 from T on to T on plus T off, right? So that is 0. So average output voltage is come out to be T on by T. This T on by T is known as alpha. Alpha is, let me write, alpha is duty ratio. Some book shows alpha, some book shows delta, right? Sometimes we call it delta, alpha or delta, right? Both are duty ratio. Clear? Now let us talk about the this control strategy. See, this alpha is having two values. this two value means alpha depends upon two factor. One is T on, other one is T. So by varying either of T on or T, we can vary the duty ratio, isn't it? Now, when we vary the T on, the pulse, the duration of the pulse is varied. This is called the pulse width modulation. It is called pulse width modulation, right? So, when we change the time period, keeping either T on or T off constant, then it is called the frequency modulation. So two type of controls strategy are available. One is frequency modulation, other one is pulse width modulation. Let us first see the frequency modulation. In frequency modulation, what we do, we kept either T on or T off constant, right? Either T on or T off constant and change the time period. For example, if you look at here, what we did, we kept this T on period constant and we changed the T off. Here it is coming in 3 square, whereas here it is 2. So overall, the total time period T2 is less than the T1. Means we have increased the frequency, right? Frequency is inversely proportional to time period. Likewise, here you can see here T off is constant. T off is constant. Here it is 3. It is also 3, but T on keeps changing. It is in 2 square. Here it is. So the total time is, you can say, the 4 square. 4 division, but here it is 5 division, right? So we are decreasing the time, means we are increasing the frequency. So this type of modulation is frequency modulation. We can also change the value of alpha by doing so. But here are some problem. What are the problem in this? That frequency has to be varied over a wide range. Why? Because if you wish to control the output voltage for the wide range, means from 0 to VDC, then you have to change the frequency over a wide range, and the filter design become very difficult for such a wide range of frequency, right? Not only this frequency range is so wide that it will also create interference in the nearby communication line. That is also undesirable feature. It is also undesirable feature. And the next problem, see, for the large of time, it may be possible that the current become discontinuous. So your motion, if you controlling DC motor, then the motion would be jerky, right? So to avoid all this, what we use the constant frequency operation and change the width of the pulse, right? We change the width of the pulse, means T on needs to be changed, right? On period of the switch needs to be changed. So as V output is equal to alpha times VDC, if we make duty cycle 25%, then output is 25% of the input. If we make 50%, it would be 50% of the input. Likewise, we do. So this is the constant frequency, or you can say the PWM control. And how we achieve it is very simple. You just use any op amp just compare the 0 with the DC voltage. Any reference voltage should be compared with non-zero. It should be compared with triangular pulse, right? Triangular or sawtooth or anyone. But for symmetry, let us say it is a triangular, and the moment this the value of the DC reference is more than triangular, it will generate the pulse. Likewise, you can generate the variable duty cycle with the help of op-amp, right? So, and the advantage of this PWM is that it is also possible कि if switching frequency is high, then load current becomes the continuous even if the load inductor is having low value, less value, means for the light load period. If the switching frequency is high, it is possible that you get the continuous current conduction mode, right? So that is the fayda or the advantage of this constant PWM control. In case of any problem, please don't hesitate to write in the comment box or direct message to me so that I can clear your doubt. Now come to the next type of chopper, which is step up or boost chopper. This is called step up or boost chopper, right? In this, what we do, we change the duty cycle such that the output voltage get increased. Now let us understand the circuit. The circuit is having one inductor, right? Whenever this switch is on, this inductor is short circuited and it store the energy. It store the energy, and you can see the current is increasing. The current is increasing. Now, when you open this switch, inductor develop a polarity in such a way that it doesn't want to that this current should decrease. So the output voltage would be equal to VDC plus LDI by dt. VDC plus LDI by dt. That will be the output voltage. We will also discuss this converter in details, but for as of now, to obtain the output voltage, average output voltage, we simply apply the basic electrical engineering. That means energy stored by the inductor is supplied to the load when the switch is open, right? And inductor store the energy when switch is on, and inductor supply the energy when switch is off. And under steady state, both this energy must be equal. Both these energy must be equal. And if I talk about the average current, so average current would be like this. Average current would be like this, I0. It is average of I max and I min. So average current is like this. Under steady state, energy stored by the inductor is VDC times I times T on, right? And when it is off, voltage across the inductor is V output minus VDC, times I times T off. This is the off period. Means when switch is off, these two energy must be equal. Right? So from here we get V output is equal to V input, that is VDC upon VDC times T upon T off. We can write T off as T minus T on, and this T would come like this. So it is 1 minus alpha. Now output is input voltage divided by 1 minus alpha. And what is the value of alpha? Alpha can vary from 0 to 1. That means Theoretically, this voltage could be infinite. When alpha is 1, VDC by 0 is infinite, and when alpha is 0, it is equal to VDC, means output voltage, the range of output voltage is VDC to infinite. It means what? Output voltage is always greater than the input voltage. Output voltage is always greater than the input voltage. It means it is boosting the voltage. Output voltage is increase as compared to input voltage, right? And for safety, we generally put the duty cycle the maximum of 85 to 90-95%. That's it, not more than that. Right? Because if this switch is permanently on, this inductor gets saturated and this switch get short circuit, right? Huge amount of current will flow. So this is the basic two type of chopper, step up and step down chopper. In next class we will discuss about class A, I mean various type of chopper, class A, class B, class C, class D, class E chopper, right? And also we will do the analysis of this buck chopper for RLE load. And this is my contact number as well as the link for channel. If you wish, you can subscribe and press the bell icon so that whenever I take the lecture, you will get the information. Bye bye. Keep doing study. Thank you.